Let me use my marker here. Yeah. So when multiplying, you have this, okay, which will be pi 1, okay, it's written down there, times what? 0.8 plus, then you multiply, okay, this and this. So it will be pi 2, okay, then times 0.4 is equals to what? Is equals to the first probability there, which is what? Pi 1. So that gives us the first equation, okay? Then we do same to obtain the second equation here. So that will be pi 1 times 0.2, like that, okay? And then pi 2 plus pi 2 times what? 0.6. That will give us the second equation here. Then, like I said, this is a 2 by 2 matrix, 2 by 2 equation. So we're going to take this other equation, okay, into consideration when solving it. So we have pi 1 plus pi 2 is equals to 1, okay? And doing so implies from this equation, we can tell that pi 1, okay, pi 1 is equals to what? 1, sorry, this pi 1. So 1 minus what? Pi 2, okay? Good. So if we are to substitute what we've just had here into any of these equations, just one of them, okay, we can substitute it into the first equation and then solve for what? And solve for pi 2. So do that for me. Substitute the third equation into the first equation and then solve for pi 2 and subsequently pi 1 as well. Okay, so I'll be waiting for your solution. I'm waiting for your solution. Yeah, Johnson. Johnson.
Hello, sir.
Yeah.
Yes, sir. This is the question I raised the issue about. Please,
Okay.
can you take us through the probability to check if the probability here given is accurate so that I know to settle my confusion?
Yeah, it's accurate. It's accurate. So the probability on the is it 0.8 plus 0.2 is equal to 1. And then 0.4 plus 0.6 is also equal to 1.
Yes, sir. But the questions was stated 0.1 and 0.9.
Let me go back a bit. So in the question, you're right. So it says being in a busy mode, it can finish a task and enter into an idle mode with probability of 0.2. So let's just, so that will be let's say state 1 and state 2, okay? 1 and 2. 1 is busy mode, 2 is idle mode. So being in a busy mode, it can finish a task and enter an idle mode at any moment with a probability of what? 0.2. Okay, so this will be 0.8 here. Then he says what? No. Then the next one is being in an idle mode, it receives a new task. Means from idle, it goes to busy mode with a probability of 0.1. This is 0.1 here. And then this will be 0.9. Okay. So let me go back to the matrix. Okay. I've seen the point you were making. Okay. So ideally, that should have been, this matrix here should have been 0. Let me go back slightly. So this would have been, okay, this matrix here should have been 0.8, 0.2, 0.1, 0.9 instead of 0.4, 0.6. Okay. But once again, it doesn't change anything. Is the process we are very interested in here. So this is 0.1. And then this is 0.9. So if we multiply, this is going to be what? Pi 0.851 plus what? 0.1 pi 2. Okay, is equals to pi 1. Then the next one will be 0.2 pi 1 times 0.9 pi 2. Okay, then the third equation is pi 1 plus pi 2 equals to 1. So you make the third equation. Okay, you make pi 1, you make it the subject in equation 3, which will be 1 minus 1 pi 2. And that is the task I was giving to you. That substitute this into equation 1 and then find pi 2 for me. So substitute pi 1 equals to 1 minus pi 2 into equation 1. Okay, I'm very specific. So substitute it into equation 1 and then find pi 2 for me.
Please say we are not hearing anything.
Oh, hello. Can you hear me?
Yeah, I can hear you now.
Yeah, I'm not playing the video. I said substitute pi 1 equals to 1 minus pi 2 into equation 1 and find pi 2 for me. So I'll pause the video. I'm waiting for you to calculate. So
Okay.
Yeah, and give me the answer. So I'm waiting for your answers.
Hello, sir.
Yes.
So please, in this case, the pi 1 that we are substituting,
Yes.
it should be substituted in both sides. That's there to be 0.8 times the pi 1.
Yes.
Which is the 1 minus pi 2 equal to the minus pi 2.
Equals to pi 1, equation 1.
But sir, with the pi 1 there and the equals to, shouldn't we substitute it there?
Yes, you substitute there as well. So that will be 0.8, 0.81 minus pi 2 equal, plus what? Plus 0.1 pi 2 is equals to 1 minus pi 2. Okay, so then you solve for pi 2. Okay, what are we getting?
Just a second.
So please, pi 2 is equal to 0.666.
Okay.
That's from my point, from my side.
So we have pi 2. Let me change this. Equals to 2/3. And then pi 1 will be what? From this equation here, that will be 1 minus what? 2/3, which will be equal to 1/3, right? So pi 1 will be equal to 1/3. Okay, so which means that we had the states as 1 and 2. 1 was busy mode, 2 was idle mode. Okay, good. So from what we have here, then it means that pi 1 is the probability of being in a busy mode. Okay, so in the long run, in the steady state of the process of that particular system, okay, the system is going to be busy with a probability of what? 1/3 here. This is busy states. So with a probability of 1/3, and idle with a probability of what? 2/3. In other words, this system is not too efficient or very effective. It's only working 1/3. That's 33%, and then it's idle about 66.6%. Okay. So the probabilities we have here, we can even talk about the efficiency of this system or the process. Okay, any question on this example before I move to the next example? Any example, any question here? Any question on the example? Yeah. So we want to watch a short clip, a short video, okay, of another lecturer, a short tutorial, okay, regarding what we've done so far. So you listen attentively. If you have any questions, then you ask. Okay. So the question says that a new rapid transit system has just started operating. In the first month of operation, it is found that 25% of commuters are using the system, while 75% are still traveling by automobiles. The following transition matrix was determined from records of other rapid transit systems. So we have rapid transition and automobile are the two possible states of what? The system, or of the traveling system, the transit system. Okay, and that's the one-step transition probability, and it's on monthly what basis. So you take note of that. Now fast forward. It says what is, so if we are given the initial distribution as 0.5 and 0.25 and 0.75, and you are being asked to find the initial state probability, all you do is to multiply the two.
Yeah, I had a comment from somebody.
You cannot hear them.
Sorry.
I used to model Qs. Okay.
Let me move back a bit. Okay, so it says what is the initial state matrix, and then what percentage of commuters will be using the new system after 2 months. Okay, and after 2 months means we'll be looking at 2-time transition probability. That's p raised to the power 2. Okay, then it says find we'll be using the new system after 1 month. Okay, so we look for the new system, okay, within p raised to the power 2. Then it says find the percentage of commuters using each type of transportation after it's been serviced for a long time. So this is steady state what? Transition probability. So let's pick the matrix. Let me write the matrix somewhere. Yeah, so this is the matrix of the system. Let's put it down somewhere. So we have the matrix is what? 0.8, 0.2, okay. And then we have 0.3, and then 0.7. Okay, now let's identify the state. So the new method is rapid transit. So let's say R. Okay, this is R. This is R. This is automobile. Okay, so this is automobile here. The new method is rapid. Automobile is the previous method. So this is it. And we're also told that it's found that 25% of commuters are using the current state, the initial state, okay, are using what? The system, while 75% are still traveling with automobiles. So in the current system for R and A, okay, we still have 0.25, 0.25, and then A is 0.75, 0.75. So per the question,